Let's now take a look at a few concepts for making cryptography more secure. And we're talking about longevity, salting, and stretching. Now, longevity refers to the measure of confidence that people have in a given cipher. In other words, it's basically the consideration of how long data must be kept secure. Now, longevity raises a very interesting question, which is, if we assume that sometime in the future, due to advancements in technologies and the introduction of more powerful computers, how long must that ciphertext resist cryptanalysis? So let's say, for example, a laptop belonging to the FBI or the CIA, basically any kind of laptop with very sensitive data. Imagine if it is stolen today. Obviously, the thief will not be able to break the encryption with the current computing resources. So, how long must that encryption mechanism continue to protect the data? Because guess what? Maybe in 5 to 10 years, due to advances in cryptanalysis, that encryption might be broken. So, the question that needs to be asked right now is, can we choose a more secure algorithm to encrypt our data so that even in 20, 30, 40 years from now, the thieves will not be able to decrypt the data if it is stolen? Now, passwords stored as hashes are vulnerable to brute force and dictionary attacks. Now, a password hash cannot be decrypted because it's simply one way. Once they are encrypted, you cannot decrypt them. However, if an attacker was to generate hashes to try and find a match for the captured password hash through a brute force or dictionary attack, the brute force attack can run through a combination of letters, numbers, and symbols, while a dictionary attack would create hashes of common words and phrases. So our password hashes are vulnerable to both brute force attacks and dictionary attacks. This is where salting comes into play. We can slow down both attacks by simply adding a salt value when creating that hash. Here is the calculation right here. Salt plus password multiplied by the SHA will equal the hash. Now, the salt itself, this is very important. The salt itself is not kept secret because the system that will need to verify the hash must know the value of the salt. However, its presence, just because we've added an extra value to that hash, that means that the attacker will no longer have the convenience of simply using a software to run dictionary or brute force attacks by making use of pre-computed tables of hashes. That's the whole point of salting. And now finally, key stretching. Now, a key stretch will take a key that's generated from a user password plus a random sort value and will repeatedly convert it to a longer and more random key. This would mean that the attacker will now have to do extra processing for each possible key values, thus making the attack even slower. Now, this can be performed by using particular software library to hash and save passwords when they're created. And there's a particular function known as the password-based key derivation function to the PBKDF2 that's widely used for this particular kind of purpose. Thank you for watching. I will see you in the next class.